We are live. All right, today's date is Monday, October 12th, 2020. Everyone has their names on their notes. All right. Our objective. Who's reading our objective? I don't need my mask on. I'm far away from you guys. Caroline.
No, you can go. I was just looking at Mark.
Yeah. Yeah, this is the penultimate lesson. Once we've done this, we are done with this unit. Can you believe that all the way back in August, the first lesson we ever did was Unit 1, and we're still on Unit 1? This is our last lesson in Unit 1. Once we're done with this, we're done with everything. But as you guys have probably guessed, we've been getting harder and harder and harder. This is the most difficult lesson of the entire unit, which means 1, we're not going to finish today, and 2, even when we finish, we're going to need a bit of review. All right, so here's my power strategy. So what am I going to do? I'm going to try to do this. All right, so I'm going to abbreviate because you guys have the full notes, so I think that's fine. So what you're going to be seeing on Khan Academy is something like this. You'll see a Chewy. Do we need to go back inside? I'm kind of cold. I'm playing. You can sit over in the sun too if you need to. If you see something of the form a plus bi, is that in polar form or is that in rectangular form? Only one person knows? Quiet, raise hands. What form is this? Is this rectangular or polar form? 2 people know. Beverly, tell us.
Polar?
No.
I said I was guessing.
It is you had a 50-50 shot, and the coin flip did not come out right. This is in rectangular form. Again, polar form would have been something like this. Polar form is r square brackets cosine of theta plus I sine of theta. If you see something that looks like this, this is polar form. So I'm giving you something in rectangular form. This is what's going to be given to you on Khan Academy typically. Something in rectangular form. And I'm going to raise this number. This is a complex number. It has a real and imaginary part. I'm going to raise this complex number to some power. I'm going to call it n because it could be anything. I can raise it to the power of 2, 3, 10. I don't know. Okay, what do you need to do in order to take some complex number to a certain power? First, you're going to find the modulus and the argument, which you guys are now really accomplished at doing. We've been doing this for like a month now, right? How do I find the modulus? How do I find this absolute value of z? That's called the modulus, the length of the number from the origin. What's the formula? I mean, you can use special right triangles, and we know how to do that. What's the formula? Just one thing that you can do over and over again.
Wait.
Question, yeah.
I have a question that I can do.
So it's one of these.
Is the modulus the angle or the?
Modulus is the length.
Then it's. Can I?
Yeah.
It's the like square root of a plus b.
Square root of something with a and b.
Yeah.
What exactly goes in here?
Or minus. Wait, plus. Plus.
There's a plus, but you're still missing some stuff.
Oh, square. A squared plus.
All right, everyone should have this formula memorized, burned into your brain. You could also use special right triangles. In fact, I will tell you guys this on the test. I will be giving you one where you can use this and one where I force you to use special right triangles. A to the power of 2 plus b to the power of 2. So that's how you find your modulus. You can also, you need to find your argument as well. This is still all in step 1. In order to find the angle, there's the special right triangle way where you say, oh, that's a 30, 60, 90. So 30 minus 180 or 180 minus that 30, it's 150 degrees. You can use those special right triangles, or sometimes you will need to use the formula. Either way, I can force you to use this formula, which you're about to tell me, or I can force you to use special right triangles. Someone tell me, what is the formula? What is the formula? One person knows. Look back at your notes. You have your notes right in front of you, right? Because you bring your notes every single day.
You see,
There's a certain trig
I'm a
function.
responsible student.
Oh, I'm not going to call an Ellery. Sorry, Ellery. It's not a one-on-one classroom.
Yeah, Ellery.
What is the formula? I see 2 people, 3 people trying to look at their notes. I'll wait so that people can find them.
A plus B I. Square root of A squared is B squared.
Chewy Jaden, do you have notes?
This was there in the classroom. I didn't know we
Okay, next time, always be bringing them regardless of where we are. If we're outside,
Tangent of
at
B
school.
over A.
So 2 people have the formula. Do you have the formula as well? Yeah, go, Caroline. There it is. Arctan, which is tan to the -1, or you can write this out as ARCTAN. Arctan of your imaginary component, your B, divided by your real component, your A. Let's take a step back. Bigger picture. What are we trying to do? We are trying to turn this into polar form. These are the steps to turn it into polar form. These are the formulas. You can also use special right triangles to turn it into polar form. Once it's in polar form, either using Euler's formula that we talked about on Monday and Tuesday, or just the long polar form that looks like this. Again, this is your long polar form. Euler's formula looks like this, RE to the I theta. One of these 2 forms are fine. Those are your polar forms. But essentially, I can boil it down even farther and say, really, Euler's formula, we only care about the theta and r. Again, absolute value of z. Another way of saying that is r. Okay, once you have that, then you can actually figure out what absolute value of z, or this argument to the power of n is, using theta and n. So step number 2, in order to find your new argument, sorry, your new modulus, I'll say your new modulus is equal to your old modulus to that power. You just take it to a power, which makes sense, right? We're trying to find the power of a polar number, a complex number, I should say. If we're doing a power, I'm really just saying, hey, the original distance, also take that to the same power. Yeah. What's up? Okay. Your new theta is going to be your old theta. And then we're going to multiply by n. So those are the 2 key takeaways that you're learning for the first time right now. When I'm taking some complex number to a power, the modulus is going to go to a power. The argument is going to be multiplied. One's going to an exponent, one's being multiplied. Make sure you know which one goes with which. And then you have to convert it back. So step 3 is convert back.
Did you do your pages? Huh? Did you do your pages?
So convert back to A plus BI form.
So the 2 things under step 2, we should write down.
So these 2 those things are already written down for you.
Because under 2 it just says evaluate that.
Yeah, it's going to be z to the modulus to a power. And it's going to be theta times that n, right? Okay, so let me re-explain this one more time. We started here. We have some complex number to some power. I could have called that power 10. If this power is 10, that means our new modulus is going to be to the power of 10 also. And it means that our new angle is going to be our angle times 10. So whatever that n was. These are the 2 key things to take away. It's going to be the modulus to the power. It's going to be our argument times whatever that power was. All right, well, I think seeing some examples are going to help. I have some stuff about special right triangles, so let me flip the board. Do I want to go this way or this way? I want to go this way. I'm not sure what I was supposed to do in the A and B. Do I make up values? Yeah, let's go ahead and make up some values. Okay, let's say I have a 45, 45, 90 triangle. So I'll label this 45, this 90. You can assume that's 45 using the fact that there's 180 degrees in a triangle. And I'm just realizing right now, can the camera even see what I'm doing? I think so, maybe. Let's go ahead and say I have a length of, what direction are you mainly going to be going? You're going to be going both directions. Let's say I have something that's like 4 right here. If this is 4, what is A? Again, here's the question. You're annotating this on your notes. I gave you a 45, 45, 90 triangle. If I say that the hypotenuse is 4, you tell me what is the length of the A. How do you find that more importantly? This is an A. If the hypotenuse of a 45, 45, 90 triangle is 4, what is the length of any one of its legs? These two legs are the same distance. They're congruent to each other. What is A? You should be doing some work off to the right-hand side. You should be saying, oh yeah, A is equal to blah, 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 blah. Doing some math.
You moved it last time because of the shade, right?
It was too hot, yeah, and it was too bright.
Now it's beautiful.
Okay, someone help me. What do I do? Beverly.
Divide by the square root of 2.
That's right. So the general operation for a 45, 45, 90 triangle, if I want to get from the hypotenuse to the leg, I divide by the square root of 2, which means if I start with 4, it's going to be 4 over the square root of 2. And I'm done, really, but I can't have a radical in the denominator. So let's practice, because we should be really good at doing this, especially by the time that the test rolls around. How do I rationalize the denominator? How do I get rid of this square root that's in the bottom? This is review from Algebra 2. See Ellery, Caroline, Beverly. Caroline. Close. Multiply by the square root of 2 over the square root of 2. Yeah. Because I can't just multiply by some random number. I can only multiply by 1 to keep it the same number. All right, Chewy. What do I have for the denominator now? Exactly. Jaden, what do I have for the numerator? Say it louder. Just kind of squish these together. 4 root 2.
I thought we were adding that. What's going on?
We were trying to rationalize the denominator. To do that, what we did was we multiplied by the square root of 2 over the square root of 2. But we're still not done. We've rationalized the denominator, but now we can simplify our fraction. 4 divided by 2 can reduce to 2. So this is actually equal to 2 square root of 2. That is the value of A. I know there's not that much room to write it there. I had to condense all these notes into one piece of paper front and back. There are teachers that I've seen online, especially now that everyone's doing stuff virtually. I've looked at other teachers, and some teachers have notes that are like 4 pages long. So I don't know, maybe I can try having notes that are longer than just 1 page front and back.
Yeah, I think you're doing perfectly fine.
Okay, thank you. Okay, let's try a 30, 60, 90. Did I draw it with the 30 degrees there? Okay, there's my 30, 60, 90. My 30-degree angles in the bottom left, 60-degree angles in the top right. Let's go ahead and make that length is 6, and this length up here is B. I know that my B's and 6's look similar to each other. I'm going to say that this length in the bottom, this long leg of the 30, 60, 90 triangle, that's going to be 6. And the hypotenuse, this diagonal distance up here, is going to be B. I want you guys to tell me how to find B and then actually find it. I'm curious. It's kind of hard to see, but you can see it. I wonder if it's reversed because I'm seeing it backwards in my camera. You have the potential to get Lyme's disease. Yeah. It'll just really mess you up. I guess yes, in many years to come.
Can you die of it?
Die of Lyme's disease just by itself? No, Lyme's disease causes other problems that you would die from. Like there's mental orders. I should really know this since my uncle almost died from it and my wife got it. All right, someone tell me, how do I find B? Someone, please restore my confidence that I passed you in Algebra 2. Oscar, yes.
You divide by the square root of 3.
To get from where to where?
From 6 to B.
From 6 to B like that?
Yeah.
Close, but not quite.
Wait, why are there 2 B's?
I'm doing my work over here.
Oh, wait, okay. I didn't do that. I thought, okay.
So you're really close, Oscar. You do divide by square root of 3, but that moves you from the short or the long leg to the short leg.
Oh, okay. That's what I was. Is there any way I can go from the?
Kind of. If you go from here to here, you could divide by the square root of 3 and at the same time multiply by 2, which is kind of hard, but it's essentially the same thing as first moving to the short leg by dividing by the square root of 3, and then from there moving from the short leg to the hypotenuse. Chewy by multiplying by 2. Chewy wants to talk so much. You're up, Chewy. Go. Yes. No, you were the one that was talking.
We both were talking.
You were talking too loud. I heard you over him. Talk quieter.
I don't know.
Divide by the square root. Wait, I wrote 2. Divide by square root of 3. That's my bad. Divide by square root of 3 and multiply by 2. Keep going. I can't have a rational 3 in the denominator. Say it one more time. I need to rationalize the denominator. I think I said it incorrectly, didn't I? All right, someone help Chewy. Chewy, calling someone. No, calling someone that has their hand raised. How do I rationalize the denominator? How do I get rid of this irrational 3, the square root of 3 in the denominator? Chewy, one person has their hand raised. Yeah. So multiply by square root of 3 over square root of 3. And look at the similarity to the last problem. In order to get rid of the square root of 2, we multiply by square root of 2 over square root of 2. Now to get rid of the square root of 3, we're multiplying by square root of 3 divided by square root of 3. All right, the denominator. How come nothing is written?
I couldn't see that.
Okay, I would start writing some stuff in. Okay, after I multiply by the square root of 3 over square root of 3, I get what? What do I have in the denominator? Oscar.
You get a 4 square root of 3.
4. Oh wow, you're that is the correct answer.
Okay,
You
well,
need to tell me how to get there.
okay, 6 times 2 is 12. And then, yeah, square root of 3 over 3 is about, and then from there you simplify 12 to 3, which equals 4 over
There it is. All right, there's our healthy serving of review. You're gonna be doing this lots and lots today. I'm on to example 1 then. I think I have all the prerequisites out of the way. I've reviewed how to work with special right triangles. You guys know the basic knowledge. Are you guys ready for example 1? I'll let you guys keep writing while I erase the back of the board.
Wait, Mr. Sindo.
Yeah.
Wait. Can you turn it around? I think like.
I'll erase this side.
Did we have to write anything for number 3?
No, you really only had to write the formulas for the modulus and
Okay, then.
yeah. Can't speak. Modulus and argument. All right, let's do this. Oh, this board does not click very nice. All right. By the way, what I'm expecting by the end of today is that you know how to do powers. If you look at the back side of your notes, you'll see that we're going to be doing something with square roots and cube roots and 8th roots and 9th roots. That's tomorrow. All right, I'm on example number 1. Here is my number. My complex number is 3/2 plus 3 root 3 over 2. I want to take that to the power of 3. So first, what do? What was our first step? Go look at your notes. It's up above. Up in example 1, it says find the and yes, next time you can raise your hand. So what is the form? And this one, you might need to use a formula. If you're tricky about it, you can see that you don't need a formula. It is actually a special right triangle. So I'll say this. You should be ready for the test where I will force you to go in one direction or the other. Maybe I'll say, find it exactly, which means use a special right triangle. Or maybe I'll just say, use a special right triangle. Don't use a formula. For right now, I'll say, use whatever you want. Use all tools at your disposal. Do you guys want to use a formula that you wrote down in the power strategy, or do you guys want to use special right triangle? I can do either way. I can do both ways if you want. Both? Which one do you want to do first? I want you guys to choose. Let's do the formula, the thing that's up there. The formula says, in order to find the modulus, this absolute value of z, I do what? Ellery gave us a formula today. What was her formula? Does anyone remember? Emily, go. What was the formula? A squared plus b squared. There it is. Which means I'm going to take this 3/2 and square it. I'll show my work. 3/2, and I'm going to square it, plus this 3 root 3 over 2 and square it. 3 root 3 over 2 and square it. And I still have the square root on the very outside. I'm going to try to write slower and neater because it's really important that you guys get these steps down. Before I was writing kind of unneat and untidy because you guys had it written down already. All we're doing right now is we're finding the modulus. We're on the first half step of step 1. All right. This rational number, 3/2, when I square it, really what it's saying is square the numerator and squaring the denominator. It's just one of your rules of exponents. So, what is that? Leo, go. 3/2 squared. Three halves squared. Square the numerator, square the denominator.
What do you want to do?
3 squared. 3 times 3. 3 times 3. There it is. 9. 2 squared. 4. All right, so Leo has squared 3/2 for us. He says it's 9/4. I just squared the numerator, I squared the denominator. Now a harder problem. And can you guys not see now? Do I need to move the board out farther? You can see? Emily, can you see? Okay. Now I'm going to square 3 square root of 3. How do I square 3 square root of 3? It's the distributive property kind of with your squares. If I have, I'm going to erase this in the top right in a sec, but let me show you my scratch work. If I have 3 square root of 3 and I'm trying to square that, what I'm going to do is I'm first going to take 3 squared and then I'm going to have the square root of 3 squared. It's like I've distributed the square into each of these terms. 3 squared turns into, you guys will all shout out at the same time, 9. And then the square root of 3 squared, shout out, is, yeah, one person got it, or 2 people, I don't know. 3, because the square and the square root cancel each other out, which means 3 square root of 3 squared is 9 times 3, which is, you all shout out, 27. All over, and then I have to square the denominator. Jaden, denominator squared, go. There it is. 27/4. We have now squared the rational function 3 root 3 over 2. I'm going to erase this work. Do you guys have this written down? You guys know how to square something that has a radical and a non-radical in it? I can erase this, nod your heads one way or the other. Okay. All right, then I add them. They have like denominators. The denominator in both of them is 4, so I can add them. I don't have to do anything else. 9 plus 27, someone will shout out. 9 plus 27.
36.
There it is, 36. You said every number that was not 36.
No, at first I said 36.
You did
Then
not
you
say.
kinda, like, kept on going. Okay, man, you heard me, Jaden. You know what I said.
And then 36 divided by 4 reduces to 9. Which is kind of cool, right? Like, look back at our original rectangular complex number. This complex number looked gross and disgusting. 3/2 plus 3 root 3 over 2. This has the exact length of 9. We haven't even finished step 1 yet. The second part of step 1 is to find the argument. So this whole front side is just step 1. Now I need to find the argument, the angle. This is the length. This is saying the length from the origin to this number is 9. Okay. Our angle, our argument. Yes. Yeah, good job. You have the extra credit tracker?
Marbles.
Oh yeah, I need to do marbles. I didn't bring them out here. That would be a marble.
That's another marble. Reminding you.
For reminding me, sure. I'll give you guys it. So I should have the square root still. Should still have the square root, and then 3. Okay, so the distance is 3. Woo! We're there. Okay. Now we're gonna find the angle. So for the angle, it's a special right triangle. You guys can use your calculators though. Let's go ahead and use our formula, right? Let's use our arctan of this 3 root 3. There should have been an I here, should there? This 3 root 3 over 2, all that divided by 3 over 2. Whoa, we can actually simplify some fractions here. I have a fraction divided by a fraction. This is really saying arctan, again, where did this number come from? It's the b divided by the a. This is really saying arctan of 3 root 3 over 2 divided by 3 halves. Which is really arctan of that 3 root 3, Jaden and Shuey, over 2. What? Jaden, you want to talk so much? Go for it.
Divided by
No.
plus.
Whenever you do a fraction divided by a fraction, you do these 3 things that you do, I've talked about over and over in Algebra 1.
Change it.
That,
Keep it.
keep it.
Change it. Flip it.
There it is. Keep it, change it, flip it. So I kept it. I'm going to change it. Jaden.
What's that? Oh, multiply.
And then I,
Multiply in the beginning. Flip it.
2a,
2 over 3.
2 over 3. There it is. Notice that your 2's are going to cross cancel. Your 3's are also going to cross cancel. And you're really saying, what is the arctangent of square root of 3? And we can't do that in our heads unless you're really, really cool, cooler than Mr. Sindel. On your calculators, make sure that you're in degrees and not radians. In degrees, what is arctangent of square root of 3? And I didn't say how many places to round here. So, oh, it's going to be a special right triangle, though, so it'll be exact. 6D? Yeah. Okay, we're still not done. Are we in the right quadrant? We have to check. We always have to check. Arctangent, it has a 50-50 shot of actually working. So we always have to draw out our number. 3 halves plus 3 root 3 halves I. Point to it. Or even better yet, what quadrant is it in? Is it in quadrant 1, 2, 3, or 4? Everyone point to it right now. I have a positive and a positive. Positive means I'm going left or right. Right, and then positive again. Yes, everyone has it now. Top right. We know we're up here somewhere, and even better yet, we know we're actually more up than we are right. Because our imaginary component has a square root of 3, which is times square root of 3 more than 3 halves. All right, which means 60 degrees is correct. We do not need to add or subtract 180 degrees. If we had that incorrect, we would have had to either add or subtract 180 degrees. Both of them would be correct depending on your domain. So we are now done with step 1. 2 more steps to go. You guys ready for this? Let me erase the back side of the board so I can continue. Oh. All right, so we have 3 and 60. These are the 2 pieces of information we got on the previous side of the board. Okay, now I'm going to do step 2.
How long is step 2?
Step 2 is going to be done in like 30 seconds here.
Okay, because I just found the first one.
Okay. Use the backside or something. I don't know. Use the summary area. Use another piece of paper. I can rip out some paper in the notebook that you handed me if you want. Okay. Remember that we're taking this to the power of 3. So I guess if you want, I can say n is equal to 3. We're taking it to the power of 3. So this modulus that I have of 3, do I do 3 to the power of 3 or do I do 3 times 3? Remember which operation goes with which? The modulus, is that to the power of or is that multiplied by? Look back at your notes. And number 2, for power strategy, do we do absolute value of z to the power of n or do we do absolute value of z times n? Look at your notes. Times? Times? No. Times is the same thing as multiply. You do it to the power of. And we're out of time. We get out of here in like 30 seconds. It's going to be, I take this 3 and it's going to be 3 to the power of 3, which is
36. 12.
27. Oh,
it's 3 times 3, which is 9, times 3 again, which is 27. And then this theta, I multiply. It's going to be 60 degrees times 3, and I get 180 degrees. And we're done. We're almost done. Stick around for 30 more seconds and we can do step 3. That was step number 2. We're done with step 2. Step number 3. Are you ready for this? Turn this back into rectangular form. Everyone point to 180 degrees. Point. Straight out to the left, which means it's a negative real number. How far do we go? We go 27. Your final answer is negative 27. Plus 0i if you want. If you want to be pedantic. But it's negative 27. That was the answer. And usually Khan Academy problems like this do come out nice. Rarely, about a quarter of the time, they do come out kind of gross. Most of the time, they come out to a nice number like this. All right, thank you guys. Stop the recording.